And thank you very much, everyone, for showing up for your learning. So we're going to start with a brief review of parallel lines and perpendicular lines. When we look at parallel lines, what can you tell me about the slope? Sorry?
Straight.
Yeah, they're both, lines are going to be straight, and they're going to go through the xy plane in a straight manner. If this line had a slope of, that looks to me like a slope of what? Like negative a third? Negative a half, maybe? What would the slope of the other line be if I told you this was negative 1/2?
The exact same.
It's going to be the same. They're going to have the same slope. Yeah, they will never intersect. How about perpendicular lines that meet at 90 degrees? What can you tell me about their slopes? They're going to be a kind of opposite, okay? And what kind of opposite are they going to be? Oh, I have a hand up back there. Yeah, one has to be positive, one has to be negative. And what else is going to be true about them? Yeah.
The number will go under 1, so it'll be in a fraction and it'll be 1 over the slope.
That's great, yeah. So let's take a look. If I draw a line perpendicular to our investment line, it's not going to have much meaning, but it will give us something that we can illustrate. So this is the line y equals 1000x plus 1000. Can someone give me the slope of a line that's going to be perpendicular to that? If I have a 90-degree angle with this line here, so this is a square, okay, that looks pretty perpendicular, and I create another line, and I wanted another equation, y is equal to mx plus some b. I don't know what b is. That's going to be wherever this touches the y-axis. That's going to be a huge number. We don't care about it. What's m?
Negative 1,000.
Negative 1,000. What flavor of negative 1,000? So this is a slope of 1,000x, and it grows by $1,000 every year. This one will be y is equal to, I have to have the 1,000 on the bottom, and the negative 1 on top.
I think the flavor should be chocolate.
Yeah, right. So it's going to be, the 1,000 has to be on the bottom, and this is on the top. So here, I have this line 1,000x. A line perpendicular to it will be negative 1 over 1,000. X. Like that. And that would be perpendicular. So they are what we call the negative reciprocal. A reciprocal means if I have a slope like 2 over 3, the reciprocal of that is I flip these two numbers, 3 over 2. Oops, that's not equals. They are reciprocals, these two numbers. Okay? For when we want the slope of a perpendicular line, they're negative reciprocals of one another. Okay? Now, reciprocals are really useful numbers to start being aware of. Like the reciprocal of 2 is 1/2. And one property of reciprocals is whenever I multiply them by each other, what do I get? If I multiply these two numbers, what will I get? 2/3 times 3/2, what will I get?
1.
I always get 1 when I multiply a reciprocal by another reciprocal. Okay? That's useful actually when you're doing inverse operations. Let's say I want to solve this equation. If I have an equation like, here, let me just get all this confusing stuff off so that we can have some space. If I have an equation like this, 3/2 x is equal to, I don't know, let's say 2. Okay? And I'm looking for a value x that makes this true. What I can do is I can notice that I'm multiplying here by 3/2, and so I could therefore do my division and divide by 3/2, both sides. Problem is, when people set this up, they can get confused. Right? It's a little easier to get confused. Another thing that you could do instead of dividing is just multiply by the reciprocal. So if I know that when I multiply this by its reciprocal, I get 1, that allows me to get down to this line here that I'm looking for, x equals something. That's my goal, x equals something. 1 times x equals something. So let's multiply this by whatever gives us 1 when we multiply it. I can therefore multiply both sides by the reciprocal. And that makes it a little easier. So I multiply both sides by the same thing. That allows me to preserve the reality of the equal sign. And then I will get here, when I do my canceling, I'm allowed to cancel this 2 with that 2. I cancel this 3 with this 3, and I'm left with x. So I have x equals, and then the result over here. 2 is the same thing as 2 over 1. And when I'm multiplying fractions, what do I do?
Oh,
Go ahead, Fisher.
you just multiply 2 and 2 into 1.
Yeah, I multiply top times top over bottom times bottom. So 2 times 2 over 1 times 3. Okay, so that gives me a 4 over 3. And there x equals 4 over 3, and I get there in one step. Okay, so that makes it a little bit easier if I understand this property of the reciprocal. And you'll start using the reciprocal a lot more to take apart equations like that. Now, some of you might have said, well, why are you allowed to do all that canceling, Mr. Jennings? If I had 3 over 2 x multiplied by 2 over 3, shouldn't I multiply top times top and bottom times bottom and then do my canceling? Well, sure. Then I'll have 2 times 3, which is 6, over 3 times 2, which is 6. 6 over 6x means I have cut pizzas into 6 slices, and you have received 6 slices. How many whole pizzas have you received? 1 whole pizza. So I don't usually write 1 times something. I don't tell you, hi, I'm Mr. Jennings, and I'm 41 times 1 years old. I can also say I'm 41 times 6 over 6 years old. It's the same thing. I'm 41. It doesn't change how old I am. I don't get any younger or older when I do that. So anyway, reciprocals, very useful idea. You're going to start using that in your inverse operations. Now let's carry on. So those are perpendicular lines and parallel lines. And if we carry on here, let's rewrite this line. And we want to write a line that's parallel to y is equal to negative 2x plus 3. And it goes through the point negative 2, 1. Okay? So let's do the work here. We know our goal is to have some equation that's of the form y equals mx plus b, right? Oops, I guess I can't zoom in there. Let's go this way. So how am I going to do that? Well, the first thing that I want to do is identify what's the slope of this line that's going to be my goal. I know that I'm looking for a line that's parallel to y is equal to negative 2x plus 3. So what will the slope of the desired line be? If I'm looking for a line that's parallel to this line, y is equal to negative 2x plus 3, yeah, what will my slope be of my new line?
Negative 2x.
Yeah, it's going to be the same as this slope. And I would say negative 2, not negative 2x, because negative 2 is my m. My m is my slope. The m multiplies the x. So I just, like in my thinking, I separate those two things. Okay. So I know that, I know this is guaranteed. M is going to be equal to negative 2. So let's go ahead and write it out as a line. Y is therefore equal to negative 2x plus some value b. I don't know b yet. I need to find that. And I'm going to find that by using this point. So how do I do that? How do I use that point to find b? People remember this from last week? Okay.
You're going to drop the coordinates into the formula, so the swap y for 1 and
Yep.
x for negative 2.
Yeah, that's right. So I'm going to substitute this in for y and x. So I'm going to substitute the y value in for there. So that's going to be 1 is equal to, oh, and I don't need, oh, geez, what happened there? I know what happened. It turned it into a, oh, don't do that. Just give me 1 inside a bracket, please. There, and I can't push space. I can. Okay, good. And then I have minus 2 multiplied by x. And so x is minus 2 here. So I have minus 2 multiplied by minus 2, and then plus some value b. Okay, so I want to be able to create this type of equation to discover the equation of the desired line. Okay, so now when I'm working with that one, I just bring it down to another line. I have minus 2 times minus 2 is 4. So I have 1 is equal to 4 plus some number. So some of you will already be able to see what that number must be. What does b have to be if 4 plus that number is equal to 1? If you're still not sure, what I would do here is I would subtract 4 from both sides. So I'm going to subtract 4 from that side, and I'm going to subtract 4 from this side. When I subtract the same thing from both sides of the equation, the equal sign is being honored, and it's still true. So now I have 1 minus 4 is minus 3 is equal to, and then here I have 4 minus 4. When I collect those terms, that's 0. So I just have b left on that side of the equation. Negative 3 is b. Now I have all the things I need to make a line that's parallel to y equals negative 2x plus 3 and passes through this point negative 2, 1. Okay? So therefore, y equals negative 2x minus 3 is the desired line. All right? Now let's go ahead and just copy this and we'll graph it in Desmos. We had this crazy huge Desmos here talking about money. Let's get a new Desmos so that we can just put that in. So there's our line that we wanted, okay? And we said that that wanted to be parallel to one of these other lines, this one here. So let's check it. Let's put this line in, copy, and then we're going to put that line in here, paste, okay? So now I see that the red line is parallel with the blue line. The reason is I chose this value m. We chose that value m because we knew it would create a parallel line. And then we created this line because we wanted to go through this point, negative 2, 1. All right, let's see if we did it. Here's the point, negative 2. Here's the point, 1. So there it is, the point, negative 2, 1. Oh, yeah, the pixels. The pixels. The pixels. Anyway, you get my point, right? That's the point, negative 2, 1. Okay. We could have also, we were solving for b, right? We needed to find that negative 3. We needed to find that this was the point where we want to touch the y-axis in order to hit that point. Okay. If we looked at that graphically, it would look like this, plus b, and then I add a slider. All right. Now, b could be any value, and if b values are too high, I'm going to miss that point, negative 2, 1. And then I come down here, and there it is. I hit the point, negative 2, 1. You see? There it is there. The point, negative 2, 1. Okay, right there. Now, what's my b value? Negative 3. All right? There's an infinite number of lines with that slope. Only one of them goes through that point. So those are the things that you can find. Okay, let's carry on. So that's how we do these types of problems, how we find the equations of lines like that. Now let's carry on. We can take a look at finding a line perpendicular to these and having the same y-intercept. This one is very fast, and I'll do this one for you. But you can copy these ideas down if you want. Here I know that I am going to have an m that's equal to, I want it perpendicular to that line, so what will my slope be? Yeah, negative 1 over 3, or 1 over negative 3, or negative 1/3 are all three different ways of saying the same thing. Great. And then I know that I can find my b. It has the same y-intercept as that line, so I'm given my b there. Okay, negative 6. All right? B is going to be equal to negative 6. I have the two things that I need for my treasure hunt, so I say, therefore, y is equal to negative 1 over 3. This is negative 1x over 3 minus 6. And that would be the desired line that I want to have there. Negative 1 over 3x, or it doesn't really matter where I put that x. Okay. So that's how I find equations of lines. All right, just a quick review of that. Now let's take a look at some more linear systems. Oh, okay, sure. So I'll go back. You can go ahead and write that down and quick review those topics. Now let's keep going. Now we are going to introduce linear systems. So we want to understand, first of all, what a linear system is. Now this is a system, and we want to be able to classify systems where we have two lines. All right, so let's take a look. What is a linear system? Well, a linear system is a system of equations. It's a set or collections of equations that we deal with at the same time. When we looked at the exponential curve and the straight line curve, we had a picture that looked like this with our straight line doing that, kind of boring and always being Mr. Steady, and then an exponential curve that was very boring at first and then suddenly became very exciting. And they passed at a certain point. And we identified that point as an important inflection point in our decision making. And that this line will always be below that line until it passes, at which point it's always going to be bigger, right? We had a system of two different equations. When we're looking at a system of linear equations, we're considering two or more lines at once, is what we are doing. Now, we also want to remember that we can rearrange lines that are in standard form into y equals mx plus b form, okay? So if I give you lines that are in standard form, some number multiplied by x plus some number multiplied by y is equal to c, we also want to be able to rearrange those into y equals mx plus b form, a slope-intercept form. These are going to be the easiest to graph, slope-intercept form. So how would I do that? Well, here you'll notice that the first step that we used was subtracting 4x from both sides. That moved it over here. And then we divided both sides by 2. And then we reduced our fractions. So this is telling me that 4x plus 2y is equal to 10 is the same thing as y equals negative 2x plus 5. And you could very quickly validate that for yourself with Desmos. I want you to get in the habit of checking your work by Desmos. It will find your arithmetic errors, if there are any, and it will highlight your correctness when you are correct, and that feels good. So definitely do that.
Is this a linear system?
No, this is just a reminder again, a review of converting from standard form to y equals mx plus b. We use inverse operations to do that. We do that by isolating the y variable is our goal, because we want y equals mx plus b. So the first thing I do is move the x over, and then I divide by the coefficient. Those are my two steps. Okay? So let's carry on. So finding the slope and the y-intercept. So we find the slope and the y-intercept from standard form. We'll find it's always these two things. And let me prove it to you on the board. So here, if we're in standard form, if I have any line in standard form, it looks like this. A multiplied by x plus b multiplied by y is equal to c. Okay? Ax plus by equals c, standard form of a line. Now, if I want to convert this to y equals mx plus b, I'm first going to subtract ax from both sides. Okay? So that will give me a new line that's by. Ax minus ax is 0, so I don't have that anymore. I just have by on this side, is equal to negative a multiplied by x plus c. Now, when I look at this, I didn't want by, I wanted just y all on its own. So my inverse operation, I see I'm multiplying by b. So my inverse operation is to divide both sides of the equation by b. So now I have finally succeeded. Y is equal to negative a over b times x. Plus c over b. Okay, so there we go. That's my any line from standard form. I could just plug in the numbers there, and it will give me that line in slope-intercept form. You could memorize that and use it. But I hope you can see that it's not that hard to recreate using inverse operations, to recreate that formula. Okay? So the slope of any line in ax plus by plus c is equal to negative a over b. And the y-intercept is always c over b. Always. Because of that. All right? So that's y, that's true. Now let's carry on. That will stay on the board so you can take a look at it. Now, there are different types of linear systems that we could have. Okay? So here is the vast majority of lines do not have the same slope. Okay? Most lines will therefore touch at one point. Okay? So these are the lines y is equal to 2x plus 1. We can see that line here. It has a positive slope. And then the line y equals negative 3x plus 1. We see has a negative slope. They touch over here. They touch at the y-intercept at 1. All right? That is most linear systems you are going to see. But humans create a lot of lines. Lines are usually human creations. Nature very rarely creates a straight line. I challenge you to go out and find some straight lines that nature creates. That would be a fun thing for you to do. And see if you see any on the way home. You'll see a lot of human lines and very few natural lines. So when lines are parallel with the same slope, there's no solution. So here are two lines. There's no solution to this linear system because there's no value of x and y that satisfies both lines. Okay? Over here, there's one and exactly one value of x and y that satisfies both lines, and it's the point x is equal to 0 and y is equal to 1. And we'll see that if we substitute that in. When x is 0, y is 1 for both lines. So that's why that's a solution to both lines. That's why they touch at that point. Here you have parallel lines that never touch. There is no solution to that. Over here, if I graph the same line twice, and that might look like a joke, and you might say, Mr. Jennings, you just graphed the same line twice. It's not two different lines. Well, I could disguise that fact from you using standard form. And I could show you tricky lines in standard form that can be reduced to other lines that are, in fact, just rearranged versions of one another. Those two lines are on top of each other. So there are an infinite number of solutions to that system of equations.
To find what again?
Sorry?
To find what? Like, why is there infinite?
Why is there infinite number?
Yeah,
Because we could have the points, because we have this same line here all the time, right? Y is equal to 2x plus 1.
Uh-huh.
So here, like the point 0, 1 is the solution to both of these lines, right?
Oh,
But any other solution I find for this line is also a solution for that line.
I guess.
For example, I go over 1 and up 2, so that would be the point 3, 1 is a solution for both lines. Let's test it. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, plus 1 is 3. So the point 1, 3 is a solution to both equations. Okay? So these are the three and the only three situations you can have when you have two lines. They either meet at one and exactly one point. Or they never meet. They're parallel. They'll never touch. Or they are the same line. They touch everywhere. So you have these three options. Infinite number of solutions, that's this. 0 solutions, that's this. And 1 solution, will always look like this. Will always look like lines that have different slopes. Even if the two line slopes is only barely different, they still will touch at some point. They still will converge and touch at a point and then diverge again. There will always be one intersection when their slopes are different. It's only when their slopes are the same and exactly the same that you get these two situations. All right, so here is a chart to take a look at that will sort of break that down for you. And then let's take a look at also what we can start putting on our handout. So we have a system of two linear equations. So this is where we're dealing with two equations or more at the same time. There could be one, infinite, or 0 solutions. And so this is a useful thing to remember. If they have no solution, that means their slope is the same, but their y-intercept, their b value will be different. They will be parallel lines. Okay? Infinite solutions means that they have the same slope, they have the same y-intercept, they have the same equation, and they have, they are multiples of one another. If there's only one solution, then the slopes have to be different. The y-intercepts will probably be different unless the point of intersection is the y-intercept. And they are unique lines. They're two lines that will always be different. They'll be different in M and they'll be different in B unless they cross at the y-intercept. So,
Hey, can I see a picture of that at least?
yeah, sure. Yeah, and I'll put the PowerPoint up on the D2L as well if you want to take a look at it again. Now let's take a look at the handout, and we're going to go through the handout together to get some ideas. Sorry, that just needs to boot up. Here we go. Boop, 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 boop. And we'll zoom in. Put me down here. Okay, here we go. And then fix the autofocus. Good. Okay, here. So let's take a look at these linear systems. Just let me get the autofocus set. That should be good. All right. So now we've been given these two lines and we want to create a sketch. Okay, so let's, how are we going to sketch these lines? For me personally, I don't like sketching in this form. How are we going to do it? How are we going to create our sketches? Yeah. Yeah, let's do it. So 3x plus y is equal to 2. I would do this on a separate piece of paper. Actually, I would just do it by using this formula that's on the board behind me and doing it in my head. But anyway, we can do it this way. 3x plus y is equal to 2. So then I have y is equal to negative 3x plus 2. And now we're in y equals mx plus b form. I just did that by subtracting 3x from both sides. So follow along on a piece of paper. Subtract 3x from both sides. Good. Now this next line, 2x plus 2y is equal to negative 4. Let's work on that one. Let's do the same thing. 2x plus 2y is equal to negative 4. Subtract 2x from both sides.
So we're trying to figure out what y of the y equals mx is.
Yeah, I would do that first before I do my sketches. So I have 2y is equal to negative 2x minus 4. Switch colors for some reason. Now I'm going to divide both sides by 2. I'm going to divide both sides by the coefficient of y. That gives me y is equal to negative 2 divided by 2 is negative 1, so negative x. Negative 4 divided by 2 is negative 2. Okay. Now I have my other line. Okay. And I can graph both of those lines with a quick sketch. Okay. So let's take a look at what my quick sketch can look like over here. All right. So I have my two lines, just going to copy them here. I'm going to put y is equal to negative 3x plus 2. And y is equal to negative x minus 2. And let's quickly do a quick sketch here. There's my xy axis. My first one crosses the y-axis at positive 2 and is very negative slopey. It goes down very quickly. It goes down with a slope of minus 3. Okay. My next line crosses at negative 2, but is less slopey. It goes down sloping this way. And it's going to cross like that. It's going to cross over here. So from that, what do I notice about these two lines when I do this? So write down some properties that you notice about the graph. I noticed that they're both negative slopes. What else do you notice? Are the slopes the same or different? They're different. Different slopes. Different m. And how about the b? Is the b the same or different? They're different too. Different m, different b. Different slope, different y-intercept. Okay? And where's the intersection? Don't give me an exact point. Just tell me which quadrant it's in. You don't know how to name the quadrants, do you? Yeah, that's fine. So I'll teach you the names of the quadrants, and you'll probably forget, and that's fine, and I'll review it often. We call this the first quadrant. The first quadrant is where x is positive and y is positive. The second quadrant is over here. We go inverse clockwise. Okay? Second quadrant is where y is positive and x is negative. The third quadrant is where both are negative. And the fourth quadrant is where both are positive. Sorry, where x is positive and y is negative. Okay? So they intersection where in the fourth quadrant. Okay? They intersect in the fourth quadrant. That's already good information. I can use that to check my answer if I check this graphically and I want to, or check this algebraically and want to know where they cross. And you can start visualizing these lines in your mind if you practice. So let's go ahead and graph these two lines in Desmos. So I'm going to go over here to Desmos. I'm going to throw these lines in. I'm going to turn that off. I'm going to turn this off. I'm going to turn this off. And turn those off. And then graph my lines. I had y is equal to negative 3x plus 2. And there's that line that's slopey extreme and crossing at the 2. And then I had y was equal to negative x. And there's less slopey. And this was minus 3. Minus 2. Minus 2. There we go. And we predicted that they would intersect in the fourth quadrant. And indeed, there they are. X is positive, y is negative. That's the fourth quadrant. Okay. Quadrant. People have that word, right? That's a new vocabulary word, or maybe a word you already had, quadrant. We'll talk about quadrants when we're talking about maps, and you can have like the northeast quadrant of a map and the northwest quadrant of a map, and a map is divided naturally into 4 quadrants by the compass rose. Quadmesters, how many quadmesters did you have? 4, and then if you have anyway, so we often use that word quad for force, so that's why quadrants, 4 areas of the XY plane. Okay. All right, so let's continue on with our presentation, with the handout. So now we can do some investigations, and now take some time now to do some investigations in your group. Get some quick sketches of these, and write the equations in slope-intercept form. Okay, great. And how are the equations similar, and how are the equations different? All right, we've already done a lot of that, and we did this. So work on these 2, and I'll come around and give you some help on these before we finish up our lesson for this morning. All right, so now let's take a look at the work you did independently. We want to take a look at these linear systems now. These 2, so let's start with this one. People have converted this to y equals mx plus b. I see some people successfully, and some people need to review. So let's write the equations in slope-intercept form. I'll take the first one, negative 2x plus y is equal to 3, and I'll write that down here. Negative 2x plus y is equal to 3. And now I add 2x to both sides, and that's going to be equal to, and I have to have 2x added to both sides. Why did I choose to add 2x? Why didn't I just add 2? Why do I have to add 2x to this side and 2x to that side? I need something to make this go away, the whole thing. I see that I'm adding negative 2x to y. So in order to get rid of that, I'm going to subtract negative 2x. Subtracting a negative is the same thing as adding. So I'm just going to do the thing that makes that go to 0. A common mistake here is to just add 2 and think I've removed that. I haven't. This is 2x. 2x is 2x. It's not 2. So I have to remember that 2x and 2 are different. Here I want to add 2x to both sides. That will give me y is equal to 2x plus 3. Okay? Now I'll do the work for the next one on another piece of paper. So I have here 4x plus 2y is equal to 6. So what were people's first move here? What was your first inverse operation to turn this one into slope-intercept form? What's our first step? I notice that I want y alone. My goal is to have y alone, and I'm adding negative 4x. So I'm going to do the opposite of that. I'm going to add 4x to both sides. Now I bring the equal sign down, and I will have, this is 4x, negative 4x plus 4x, that's 0. Now 2y. 2y is equal to 6 plus 4x. Okay? But with this one, I need to do one more step. What do I need to do now to get properly into y is equal to sum m times x plus b? What do I need to do here? Yep. Why are you choosing to divide instead of subtract?
Because we're trying to get rid of since we have
Hard to explain?
yeah.
Okay, no problem. That's why I'm here. I need to divide here because I'm multiplying. I know 2y is equal to 6 plus 4x, but I want to know what 1y is, not 2. So to find out, I'm going to divide. Let's say I had 2 elephants on one side of a scale, and the other side said 20,000 pounds. How heavy would one elephant be? 2 elephants on one side, 20,000 pounds on the other. If I divide by 2, if I divide the number of elephants by 2, how heavy will it be? 10,000 pounds, right? It's 20,000 pounds over here. I have 2 elephants. 10,000 pounds per elephant, okay? You divide on both sides of the equation, it will still be true. Okay? So I'm going to divide both sides of the equation by 2. Then I have y is equal to 4x over 2. Well, that's 2x. 4 divided by 2 is 2. 6 divided by 2, that's 3. So there I have y is equal to 2x plus 3. Okay, let's just copy it down. Oh, we already had y equals 2x plus 3. Oh, we already had that. These two lines, what did we just learn about these two lines? They're the same. Yeah, the same line. So I have this line times 2. Oh my goodness. So when I sketch that, first of all, what's my sketch going to look like? What's my y-intercept here with this line? Y is equal to 2x plus 3. What will my y-intercept be? 3. Yeah, so it's going to be a point 3 above 0. So it's going to be up there. And it's going to have a positive slope. That means as x gets bigger, y gets bigger. And it gets bigger by a slope 2. So it looks something like this. Okay? And I have that line twice. How are the equations similar here? M equals M and B equals B. Therefore, they're the same. They're the same. Maybe it was hiding from us here because they were in standard form and this one wasn't reduced yet. But you'll notice if I divide this equation by 2 both sides, I'd get that equation. They're the same. And that's why when I graph it, I can only graph one line. Or I could go ahead and take another color and graph right over that line, and that would also be fine. Okay? Because 2 lines are the same. Okay? So what are the properties I notice about the graph? The 2 lines are the same. Okay. Now this one here, did people find their y is equals mx plus b's for these ones? Or can I just do it in my head? Go ahead.
So it's y equals 2x plus 3.
Yeah.
And then
2x plus 3. Yeah, that's this one rearranged. And I see that you added 2x to both sides. Great. And then this one?
yeah, that one's y equals 2x plus 4.
Yeah, 2x plus 4. Great. So I see that you added 4x to both sides and then divided by 2. Okay? So that would have given you this equation. Great. Now if I sketch that, one has a y-intercept of 3, one has a y-intercept of 4. This one is going to increase at the same rate that this one does. They have the same slope. They're parallel. They'll never touch. So what properties do I notice? Parallel. The equations in slope-intercept form. The m's equal m's, but the b's do not equal the b's. The b's are different. 3 does not equal 4. They're close, but they're not the same. How are the equations different? Okay, b is not equal to b. That's how they're different. Okay? So that's how I noticed 2 lines are the same. Infinite number of solutions. The 2 lines are parallel, no solutions. And the 2 lines touch at one point means that the 2 slopes must be different. So the equations are similar, the equations different. M does not equal m for these. The 2 slopes do not equal one another. And then we have equations that will meet at one point and one point only. So those are the 3 different situations that we can have that are possible when we look at 2 lines in the xy plane. After the break, we'll take a look more at how we find the exact point of intersection using a graph.